Well, here we are in Math 20-1. We're on topic 1.4 on geometric series. A geometric series is the expression for the sum of the terms of a geometric sequence. Let's do an example. A school district emergency fan-out system is designed to enable important information to reach the entire staff of the district very quickly. At the first level, the superintendent calls two assistant superintendents. The two assistant superintendents each call two area superintendents. They in turn each call two principals. The pattern continues with each person calling two other people. At every level, the total number of people contacted is twice the number of the people contacted at the previous level. The pattern can be modeled by a geometric series where the first term is 1 and the common ratio is 2. The series for the fan-out would be 1 plus 2 plus 4 plus 8, which gives a sum of 15 people contacted after 4 levels. To extend this series to 15 or 20 or 100 levels, you need to determine a way to calculate the sum of the series other than just adding the terms. So here's the superintendent calling two people. They in turn call two people. They in turn call two people. So at the first level is a 1, second level is a 2, next level is a 4, and next level is 8. So there we have a geometric series. So we're going to say the sum of a geometric series can be determined using the formula S of n is equal to the first term times the common ratio to the power of n minus 1, all divided by the common ratio minus 1. R cannot equal 1. If R was equal to 1, we wouldn't have a series. T1 is the first term in the series, n is the number of terms, R is the common ratio, and Sn is the sum of the first n terms. So let's look at an example. Determine the sum of the first 10 terms of each geometric series. If we started with 4 plus 12 plus 36 and continued, the first 10 terms, well, we know that the first term is going to be 4. Now we have to find R. And, well, we know that the number of terms, is going to be 10. Now we'll find R. R is going to be term 2, which is 12, divided by term 1, which is 4. So R, our common ratio, is 3. So now we're going to take this information and plug it into the formula from above. And we're going to say Sn is equal to T1 times R to the power of n minus 1 over R minus 1. When we substitute, S of 10 is what we're trying to find. Term 1 is 4. R is 3 to the power of 10 minus 1 over 3 minus 1. Now the best way of doing this is to use your calculator. You're going to go 3 to the power of 10 minus 1 equals, get your answer, times that by 4, get your answer, and then divide that answer by 3 minus 1, which is 2. And what you should find is that your final answer is going to be 118096. Those are the steps. Let's do B. This time our common ratio is a fraction. But since it's 1/2, it's a terminating decimal, we're going to use a terminating decimal. So now Sn is T1 times R to the power of n minus 1 over R minus 1. We have Sn is going to be first 10 terms, so S of 10 is going to be 5 times 0.5 to the power of 10 minus 1 over 0.5 minus 1. Now we're going to get some messy decimals here, but your calculator, leave them in your calculator and work with them. It's okay. When I put in 0.5 to the power of 10, I'm going to get a very long decimal in scientific notation, which I'm just going to write out in standard form as 0.0009765 minus 1. And when you take that decimal, even in scientific notation, subtract 1 equals, times it by 5, get the answer and divide it by negative 0.5, you're going to get this answer, which then you can press in your calculator, math 1, enter, and that's going to convert this into a fraction, and that fraction is going to be 5115 over 512. And that's a perfectly acceptable answer. In example 2, we're going to determine the sum of a geometric series. This time, though, we've got an unspecified number of terms. For A, 1 over 27 plus 1 over 9 plus 1 over 3 plus is going to end up at plus 729. Well, always the same. We need to figure out what term 1 is, then we need to figure out what our common ratio is, and then we have to figure out how many terms there are going to be. So term 1 is 1 over 27. The common ratio has got to be the second term, 1 over 9, divided by the first term, 1 over 27. And you all remember how to divide fractions. 1 over 9 divided by 1 over 27 means that you're going to multiply by the reciprocal to get 1 over 9 times 27 over 1. Multiplying straight across, you're going to get 27 over 9, which is 3. So now we have our common ratio 3, and our first term 1 over 27. And now we're going to do and use the general term to figure out how many terms there are. What is n? So we're going to say Tn is equal to T1 times r to the power of n minus 1, and we're going to use the general term to find n. We know Tn is the last term, which is 729. That's going to equal the first term, 1 over 27, times the common ratio, which is 3 to the power of n minus 1. Next step is to multiply both sides by 27. That's going to get rid of the fraction. So if I multiply the right side by 27, that's going to get rid of the fraction. The left side, when I multiply by 27, I'm going to get 27 times 729. Now what I'm going to do is I'm going to express 27 and 729 both as powers of 3. So 27 is 3 to the power of 3. 3 times 3 is 9 times 3 is 27. 729, if you go 3 times 3 times 3 times 3 in your calculator, you'll find it's 3 to the power of 6. So that's going to equal the right side, which is 3 to the power of n minus 1. To simplify this, we have 3 to the power 9 is equal to 3 to the power of n minus 1. So that must mean that 9 is equal to n minus 1. And if 9 is equal to n minus 1, I can add 1 to both sides to find n is equal to 10. Now we know that there is going to be 10 terms in this geometric series. Now I can use my formula to find the sum. I know all the information, just have to plug it in. The sum of the first 10 terms is going to be T1 times r to the power of n minus 1 over r minus 1. And that'll be 1 over 27 times 3 to the power of 10 minus 1 all over 2, because 3 minus 1 is 2. Again, if you use your calculator, start with 3 to the power of 10, enter, minus 1, enter. Now, to multiply by something by 1 over 27 is the same as dividing it by 27. So take this number, divide it by 27, enter, then divide it by 2, and you're going to get a final answer of 29524 over 27 after you take that decimal and press math 1, enter. B. This time I've got a negative common ratio. I can tell because the numbers go positive, negative, and they end in a negative. So I'm going to say my first term is 4. That's easy. My common ratio is negative 16 over 4, which is negative 4. And now I need to figure out how many terms there are. So again, Tn is T1 times r to the power of n minus 1. The last term is negative 65536. Term 1 is 4 times negative 4 to the power of n minus 1. First thing I'm going to do to solve this is divide both sides of this equation by 4. And I get negative 16384 is equal to negative 4 to the power of n minus 1. My next step is to express negative 16384 as a power of negative 4. So I'm going to start out. I'm going to say negative 4 times negative 4 times negative 4, enter, times negative 4, enter, times negative 4, enter, and I'm going to find that negative 16384 is actually negative 4 to the power of 7. So I'm going to express negative 16384 as a power of negative 4. Now I know that 7 has to equal n minus 1. The exponent has to equal the exponent. And that means by adding 1 to both sides, n is equal to 8. Now I know how many terms there are, and I can say that the sum of the first 8 terms, or all 8 terms, is 4 times negative 4 to the power of 8 minus 1 over negative 4 minus 1. So in your calculator, you're going to follow these steps. You're going to go bracket, negative 4, bracket, to the power of 8, enter. You should get 65536. Now you have to subtract 1 from that, enter, times 4, enter. You should get 262140. Now all of that can be divided by the denominator, which is negative 5, enter. And that'll give you your final answer of negative 52428. Make sure you carefully put that into your calculator, or do it in steps as I did on the first example, to figure out your correct solution. Your assignment for this section is to do page 53, numbers 1 to 10.